In a vast and ancient cosmos where the human mind seeks answers, the absence of signs of intelligence may not only be the result of cosmic filtering, but rather of a silent echo, revealing that the universe has not yet reached its maturity to harbor the complexity of conscious life. We, humans, arose too early, and perhaps we won't be present when the majority of life begins its journey in a much more conducive environment than what we currently observe.
Currently, the universe we know is 13.8 billion years old. From our life perspective, it seems like a long time. However, when we compare this age with the future, it becomes almost insignificant. In one of the possibilities considered as a possible end of the universe, astronomers predict that at some point in trillions and trillions of years, the universe will face the so-called Big Crunch in a gravitational collapse. This means that before this happens, the universe still has an unimaginable and very long time to exist and evolve. On this timescale, 13.8 billion years is as if the universe has just come out of the cradle and started taking its first steps on the vast stage of space and time. Therefore, as ancient as our civilization may seem on a human scale, perhaps we are an exception in a universe still very hostile to support advanced life. Beyond the perspective of the cosmic timescale, other evidence reinforces the idea that we are one of the first civilizations in the universe. The primordial universe was mainly composed of hydrogen and helium, and this process took hundreds of millions of years to occur. Only after this period did the first stellar clusters begin to emerge, where the abundance of heavy elements, fundamental for complex life, such as carbon, oxygen, and iron, was forged only in the first generations of massive stars and disseminated through supernovae. Without this initial distribution of heavy elements, complex life forms like us could not have arisen. Added to this, we have the formation of rocky planets similar to Earth, a time-consuming process on a cosmic scale. Even having gathered the basic conditions for the emergence of life, such as the presence of rocky planets and heavy elements, the very origin of life still represents a huge challenge. Proposed theories, such as the primordial soup or the RNA world, suggest that leading simple molecules to organize into complex living systems may have been an extremely rare and improbable process. However, even after overcoming this initial barrier, the evolution of simple life forms, such as unicellular microorganisms, into complex multicellular organisms, and eventually intelligent beings like us, presented another major filter. This process took billions of years of gradual adaptations in countless lineages that failed and became extinct. And that's where the Fermi paradox, proposed by the Italian physicist Enrico Fermi, gains strength.
Now we have surveyed large chunks of our galaxy. The Sloan Digital Sky Survey has taken spectroscopic observations of more than 2.5 million stars. Those stars, almost all, have planetary systems as discovered by the Kepler Space Telescope, watching the minuscule dimming of light as distant alien worlds pass in front of their parent star. We've now determined that almost every star in the Milky Way has a planetary system, and there are tens of billions of terrestrial, so Earth-like planets with the potential to have life-loving liquid water.
If the universe is so old and vast, why don't we see evidence of other intelligent civilizations beyond our own? One possible explanation is that although the basic conditions may be common, the filters for the emergence of life, and subsequently intelligence, are so improbable that in fact, we are one of the few or perhaps the only civilization to have arisen so far. Another possibility is that once a civilization reaches a certain technological level, it simply self-destructs through conflicts or the exhaustion of resources on its home planet. In addition to these points, we have to consider that our solar system seems to have an extremely unique and favorable configuration for the emergence of intelligent life. Characteristics that have proven rare when we observe other systems in the deep universe. We have the privileged location of Earth relative to the Sun, but we also have the presence of Jupiter on a stable trajectory. It is believed that with its immense gravity, despite potentially bringing problems, it also acts as a cosmic janitor, preventing many asteroids and comets from colliding with Earth in its early days, allowing for the peaceful development of life. There are still other points, such as the ideal size and composition of our Sun, an exceptionally large moon that stabilizes the Earth's rotation axis, and the location of the asteroid belts that provided water and organic materials to the inner planets. This configuration makes the solar system a true paradise for the flourishing of complex and intelligent life. However, some argue that the Sun itself may not be the ideal type of star to harbor intelligent life in the long term because it has a relatively short lifespan, shining brightly for only a few billion years before exhausting its nuclear fuel and collapsing. This time scale may be insufficient for the development of advanced life forms that can overcome evolutionary obstacles. The future of the universe holds the formation of stars as stable as the Sun, but in numbers, trillions of times greater than what is currently observed. Comparing the universe of today that we live in with that of the future is like thinking of a desert where in the current time we find an oasis, and there will be trillions of them, giving chances for any kind of life to interact between them, significantly increasing the chances of prolonging it. However, even if intelligent civilizations arise around these stars, due to the accelerated expansion of the universe, they could remain forever isolated in their own galaxies, without the slightest chance of contact with other civilizations in other galaxies. But notice that even with this perspective of being the first, it is still considered that there is a possibility that others have arisen along with or before us, with some having arisen in our own galaxy. The reason we haven't observed them yet may be because we are limited by the time it takes for our communications to reach other star systems. In the case of Earth, this communication would have reached only 100 light-years away, a very short time to reach most stars close to the 120,000 light-years of the Milky Way, going further reaching the nearest galaxy to ours, 2.5 million light-years away, and the 93 billion light-years of the observable universe, considering that it is expanding in all directions, including upwards and downwards from our perspective.